Hello, ladies and gentlemen. This is Michelangelo Ilusorio, and today we will discuss about motion of charged particles in electric and magnetic field. So, what is motion of charged particles in electric and magnetic field? Imagine a microscopic world where tiny charged particles are in a constant motion. Now, I introduce the two unseen forces that can push, pull, and bend their bands, the electric and magnetism. We refer to this fascinating relationship as charged particle movement in electric and magnetic fields. Let's explore these intriguing details. First, what is charged particles in electric field? In electric field exists around any charged object. It exerts a force on other charged particles, either attracting or repelling them, depending on the signs of their charges. Imagine a positively charged particle encountering an electric field. The field will push it in the direction opposite the field lines, while a negative particle would be attracted. This electric force can accelerate the particles, changing its speed. On the other hand, magnetic fields. The magnetic fields, unlike electric fields, don't directly accelerate particles. Instead, they exert a force perpendicular in both the particle's velocity, speed, and direction, and the magnetic field itself. This force acts like a giant invisible hand, constantly curving the particle's path without affecting its speed. Think of it like spinning a ball on a string. The string, as magnetic field, guides the ball as particles' path but doesn't change its speed. So, what will happen when electric and magnetic fields collide? Now, when both electric and magnetic fields are present, the particle experiences a combined force, the Lorentz force. This force takes into account the influence of both fields and determines the resulting trajectory. Here's what can happen. First, in a circular motion, if the particle's initial velocity is perpendicular to the magnetic field and the electric field is zero, the Lorentz force acts as a centripetal force, causing the particle to move in a circular path. Imagine a charged particle spiraling around our magnetic field line like a tiny dancer. In a helical motion, if the particle has a velocity component parallel to the magnetic field along with a perpendicular component, the combined effect creates a helical path. The particle spirals along the field line while also drifting sideways due to the electric field's influence. Lastly, straight line motion. In rare cases, if the electric and magnetic fields perfectly cancel each other out in a specific direction, the particle can travel in a straight line at constant speed. For the formula that we will use is Lorentz force. This force combines the effect of both electric and magnetic field on the charged particle. It's calculated using the following formula. F is equal to Q V times B plus QE. F stands for force acting on the particle. Q stands for charge of the particle. V is for velocity of the particle. B is for magnetic field strength. E represents measure of the force exerted by an electric field on a charged particle per unit. Here's some example application in the real world. Particle accelerator. These devices accelerate charged particles at extraordinarily high speeds using electric and magnetic fields. Televisions. The visual you see on your screen are produced by the manipulation of electrons in a cathode ray tube or CRT by magnet and electric forces. In conclusion, charged particles moving in electric and magnetic fields provide a fascinating demonstration of how fundamental forces influence matter's behavior. Understand this interaction will enable us to create groundbreaking technologies that will change our reality, in addition to help us solve the atomic mysteries of the cosmos. This microscopic dance is a topic worth investigating further since it could lead to groundbreaking development to science and engineering. In simple terms, studying how tiny change particles move in electric and magnetic fields is like watching the building blocks of nature in action. By figuring this out, we can not only understand the tiniest thing around us, but also invent amazing new things. It's a super important area of science. I hope you guys learned something from this. Thank you and have a good day.